All right, dudes, here we go. Part 2. We're going to solve by canceling logs. All right, and in this case, you must check for no solution, okay? All right, so sometimes you're going to end up with extraneous solutions, okay? All right, so let's go ahead and start. Here's my first example. I have the log base 5 of 5x plus 9. Okay, and that equals the log base 5 of 6x. All right, and let me show you what I mean by canceling logs, okay? Check this out. If I have the log of 7 equals the log of x, can you tell me what x equals? Of course. The only thing that makes sense here is the log of 7, right? The log of 7 equals the log of 7. So you don't even need to look at the logs, okay? It's just cancel the logs out. You get 7 equals x, okay? What if I put something like this here? The log base 3 of 7 equals the log base 3 of x. Did that change anything? Okay? No. The log base 3 of 7 has to equal the log base 3 of this, whatever that is. It's the only thing it could be is 7, okay? So the only time it does matter is if, say I have something like this. The log base 8 of 7 equals the log base 3 of x. That's not really gonna, okay? We can't cancel the logs in that case, okay? All right, so here we go. Let's do this. The log base 5 of this equals the log base 5 of this. That means that this has to equal this, okay? So you can get rid of these, okay? Cancel the logs, okay? All right, and we are left with 5x plus 9 equals 6x, okay? Move the 5x over, we get 9 equals x, okay? All right, now if you plug that in, you get 45 plus 9 is 54. The log base 5 of 54, you'll plug that into your calculator. Sure, you get a number. And then plug in the 9 here. The log base 5 of 6 times 9 is 54. Okay, log base 5 of 54 equals log base 5 of 54. Yeah, that's totally cool. This is a great answer. Okay, let me show you an example when it might not work out. Okay, we have the log base 6 of 3x minus 10 is equal to the log base 6 of 14 minus 5x. All right, now this is where it might not work out, okay? All right, notice it's the log base 6 of this equals the log base 6 of this. You don't need these logs. You know that this has to equal this. So 3x minus 10 equals 14 minus 5x. We'll solve for x. Add the 5x to the other side, you get 8x. Add the 10 to the other side, you get 24. Divide by 8, you get x equals 3. All right, now that looks all great and wonderful, okay, until you plug it in. Watch what happens. If you plug a 3 in right here, what do you get? 3 times 3 is 9. 9 minus 10 is negative 1. Let's just see what happens if I try to take the log of negative 1. Now I know it says log base 6 of negative 1. I'm just going to show you really quick the log base 10 of negative 1, okay? So here I'm going to hit the log button. That's log base 10. And I'm going to put negative 1, and let's see what happens. What? It says error, non-real answer. That's because you cannot take the log of a negative number, okay? Can't do it. Okay, so the one thing that you need to know is you cannot take the log of a negative number. Okay, so you want to have that written there. Okay, so this does not work. Okay, that is not a good answer because when you plug it in, you end up getting the log of a negative number. Not going to happen. Okay. Let's do part D. All right, let's see if I have room here. Yeah, I have room here for part D. we're going to solve by switching to exponent form. Okay. And here we go. Let's do a first example. We have the log base 4 of x is equal to -1. Okay? This is straightforward. Okay? We're trying to figure out 4 to what power gives you this, and we're trying to figure out what this is, right? Well, what's the power? Remember, logarithms give us the power. So -1's the power. So 4 to the power of -1. Okay, you could do this in your head, you get 1/4. But let's just switch forms, okay? What's the base? The base is 4. What's the power? -1. What's it equal? It equals x. And now just plug that into your calculator if you can't do it in your head. 4 to the power of -1 is 1/4. That equals x. All right, let's do one that might be a little more complicated, okay? So that was just to get us started, switching to exponent form. All right, let's try this. Here we go. Make sure I'm lined up here. All right. We have 1/3 times the log base 5 of 12x okay, 1/3 times the log base 5 of 12x, and it equals 2. All right, so here we go. First things first, we want to switch this into exponent form, but we can't really do that yet. I mean, we can. Actually, you know what? There's a lot of ways you can do this. I noticed this 1/3. I was almost tempted to take this 1/3 and put it as the power for the 12x, but I'm not going to do that. I'm going to actually multiply both sides by 3, and watch what it happens. I get log base 5 of 12x is equal to, multiply this by 3, it cancels, multiply this by 3, and I get 6. It's probably the best way to do it, although you can do it the other way, move this to the power for the 12x, but it gets crazy. So this way is going to be nice and easy. So now let's switch forms. What's the base? The base is 5. What's the power? The power is 6. What does it equal? 12x. Okay, now what's 5 to the 6th power? There we go. Let's go 5 to the power of 6. 15,625. 15,625. That equals 12x. You could do the rest. Divide by 12, right? And x equals, so I'll divide that by 12. X equals 1302. 1302.08. So 1302.08. Okay, that's my x. All right, let's do one last one that's going to be crazy. All right, let's do one last one. It is the log base 2 of x. All right, plus the log base 2 of x minus 7, and that equals 3. Okay, I think this is a kind of a fun one. All right, we're supposed to switch to exponent form, right? But we have 2 logs, right? Which one do I choose? Okay, you don't choose either one of them. You need to condense them into one logarithm. Okay, we need to condense these into one logarithm. So this is going to be the log base 2 of something, right? We're condensing it into 1. Now if you notice, it's a plus sign in between the 2. So it means that if I condense it, this x and this x minus 7 are going to be connected by multiplication. So this is the log base 2 of x times x minus 7. Right? Here, let me show you this. Remember how we did this? If I had the log base b of m times n, and I said, hey, let's expand it. Wouldn't that turn into the log base b of m plus the log base b of n? Okay? So if I'm condensing them into 1, it goes backwards. It's the log base b, just one of them, and then it's this times this, the m times the n. Okay? We're doing the same thing here. This is like the m, and this is like the n. So it's this times this. Okay? And then that equals 3. All right, and now let's switch forms. Okay, what's the base? Good, the base is 2. What's the power? The power is 3. What's it equal? It equals x times x minus 7. All right, and now there's a couple things we need to do. First off, we need 2 to the power of 3. Okay, don't say 6. Don't say 6, that's 8. Equals, now distribute this, we get x squared minus 7x. Are you thinking what I'm thinking? I think so too, it's quadratic. So I'm going to move that 8 to the other side. So 0 equals x squared minus 7x minus 8. And now I have to factor. Okay, x and x. I'm thinking 8 and 1. Okay, I need a negative 7, so it's going to be a negative 8 and a positive 1. All right, and here we go. We get x equals 8 and x equals negative 1. Now, there's something we need to try really quick. Okay, remember what we couldn't do in this last section? We couldn't take the log of a negative number. Remember when we plugged in 3? We got 9 minus 10 is negative 1. You cannot take the log of a negative number. So if you go back over here, let's plug in an 8. Can I take the log of 8? Sure. Plug in the 8 here. 8 minus 7, that's 1. Sure, I could take the log of 1. Plug in a negative 1 right here. Log base 2 of negative 1. Can I take the log of a negative number? No. This guy is not a good answer. Okay? All right, guys. I hope that was helpful. If you need more help, you know where to find me. I'll talk to you soon. Peace.